Today we're going to look at graphs of cosines and sines with translations. Our objective is to be able to find the amplitude, period, phase shift, and vertical shift of cosine and sine graphs, and to be able to graph those given their equation. So first, where do these graphs come from? Well, they come from the coordinates of the unit circle. So here's an example of our unit circle, and what we're going to first concentrate on is our graph of our cosine. And if you remember, cosine are our x values. So if I look at the x values as I go around the unit circle, that would give me my points to plot to get my graph. So if you notice, cosine at 0 degrees, or 0 pi, starts at 1. At pi over 6, it's root 3 over 2. Pi over 4, it's root 2 over 2. Pi over 3, 1/2. Pi over 2, it's 0. And then so on all the way around. Well, I can use those points to help me plot my graph. So what would that actually look like? Well, when we look at the graph, it's not our normal coordinate plane. We kind of have this longer axis that represents the angle measures, and then our y-axis will represent the actual values that we get for cosine as we go around the circle. So if you can think about it, we have all these individual points, but at 0 pi, we're at the point 1, 0, so our value is 1. Now we have all these points in between, but the next nice, easy one to graph is at pi over 2, we have the value 0. And then if we go around the circle again, once we get back to pi, the x value is -1. And then as we move around more, we get to 3 pi over 2, and we're back to 0. And then finally, as we go all the way around, we get to 2 pi, we're back up at 1. I can draw a smooth curve. And this is what the basic cosine graph would look like. Now if you notice, in between, from 0 to 90 degrees, or 0 to pi over 2, I actually have other random values. And those values would occur at 30 degrees, 45 degrees, and 60 degrees at our root 3 over 2, our root 2 over 2, and our 1/2. And that would continue on throughout our curve. So if you notice, at 0 radians, we start at 1. At pi over 2, I go to 0. At pi, I go to -1. Then 3 pi over 2 at 0. 2 pi, and back up at 1. So it kind of has a pattern at, if we start at 0, at high, middle, low, middle, high. And if I keep going around the unit circle, if I was to go to the next value past 2 pi, okay, or 5 pi over 2, it would actually get back down to 0 again, and then continue on with our pattern. If we were going to do the exact same thing, but look at the y values going around the circle, that would give us the graph of our sine graph. And again, what we're going to concentrate on are what are the angle measures as we go through there. Now if you notice here, at 0 radians, the sine value is 0. Pi over 6, we could then go up to 1/2, root 2 over 2, root 3 over 2, and then we go up to 1. The numbers start to get bigger, because if you notice, our y value is getting higher, and then we start to go back down again. Our y's are getting lower until we get back down to 0. Then our y's start to go into the negative until we get to -1, and then they start to increase until we get back to 0. So if we went through again and tried to graph this at 0, we actually had a y value of 0. The next nice pretty number was at pi over 2, which was a value of 1. If I went back around our unit circle, at pi we were at 0. At 3 pi over 2, we were at -1. And then all the way around to 2 pi, we were back to 0. So if I draw a smooth curve through this, this is what my sine curve would look like. Very similar to the cosine curve, except we start at the middle, then go to the highest point, middle, the low point, middle. And again, if I was to continue this and say go on to the next one, which would be 5 pi over 2, that would be back at our 90 degrees. If I look at my coterminal angles, this would go back up. And this would continue over and over and over again. So here are our basic equations for the standard form for cosine and sine functions. If you notice, they're the exact same, except the cosine function will have a cosine, the sine function will have a sine. We have 4 terms, just like all the other translations we've done this year. We have an A, a B, a C, and a D, and they're going to do a lot of the similar things, especially our C and D, that we're used to that it did with, for example, when we moved our absolute value graphs or our quadratic functions. And I'm going to go through now and tell you what each of those letters do to our graph. So the A helps us find what we call the amplitude, and it's always the absolute value of A. Okay, so if you remember this symbol, this is the absolute value. So if A happens to be negative, that's okay. We take the absolute value of it, and that gives us what we call our amplitude. So let me explain what that is. So say we're dealing with a cosine graph, and it goes something like this. Okay, our graph continues. What the amplitude is, it's the distance from what I like to call our midline, the line that will basically cut our graph in half. And if I find the distance that we move either up or down from this line, that is what we call our amplitude. And that's our little a. And the reason why we do the absolute value is because this is a distance, and we know distance must be positive. Now, if the a is negative, just if you remember when we had, say, a quadratic, y equals x squared, if you remember that looked like this, well, what had happened when I put a negative in front of it, it reflected it. And it happens the same thing here. If a is negative, we will reflect the graph over the midline. So for example, what that would look like is this. Instead of being at the high point, it would be at the low point. It would just flip, reflect our graph over that middle line that I have drawn. That's what would happen if a was negative. Okay, but the distance still is written as a positive answer. The B helps us find what we call the period of the graph. So again, I'm just going to deal with the same graph. I'm going to extend it a little bit further. All right. Period is how long it takes the graph to repeat. So for example, if I start here at the high point, go high, the middle point, then I go low, then I go middle, then I go high, and then middle, and then low. If I can find a part of this that repeats, so if I look at this part of the graph, if you notice, once I get to this point, it starts to repeat itself. Well, that's what we would call the distance from here to where it repeats. This would be 1 period, okay? Or we sometimes call it 1 cycle. The length from here to here, so for example, in this cosine graph, this would be 0, this would be 2 pi, the period would be 2 pi. So that's what the period is. We have a little formula to find it. Because the graphs we're talking about right now, sine and cosine, they actually have a period of 2 pi. If I change the b value of my equation, that will actually change how long it takes to repeat. So for example, maybe the graph does this instead. Okay, it repeats more often. Or maybe what happens instead is it stretches it out and it takes a really, really long time for it to repeat. So if anyone is familiar with music, okay, or even if you think about heartbeats or anything that has some sort of graph like this, okay, if this repeats more often in music, this would be a higher pitched note. And if it takes longer, the period is longer, it would be a lower pitched note. Or if you think of a fast heartbeat and a slow heartbeat. Okay. C does the things that we're used to. It's our phase shift, or in the past we've called it a horizontal shift. When we're dealing with trig functions, we call it a phase shift. That's how much the graph is going to shift left or right. And if you remember from before, if you are adding C, we actually move that many units to the left, and if we subtract C, we move that many units to the right. Anytime you have a formula where there's a minus sign in front of the symbol, and for example, in this part of our equation, it's the x minus c part of our equation. Anytime you have a minus sign inside one of your formulas or your equation, that means you're going to do the opposite. So if it's a minus, you're really going to look at it as a plus because you're subtracting a positive number. If you see a plus, what's really happening is you are subtracting a negative value. So that's why we do the opposite of what it would look like. So again, if we're adding, say plus 5, we're really going to move left 5. If we're subtracting 5, we're really going to move right 5. Now, the D is our vertical shift, how much we move up or down. And if you remember in our formula, it says plus D. Because it's a plus sign, we're going to do exactly what we think. If it's positive, if we're adding D, we're going to move up. And if we're subtracting D, we're going to move down. So what we're going to do now is I'm going to put all of these numbers together and show you how we're actually going to use our basic graph and shift. It's just going to be like what we did before. We use this parent graph, what our basic cosine and sine graphs look like, and then we're going to take those points and shift them left, right, up and down, and reflect them to get our new graph. So here's our first example. Okay, it's got a lot of different numbers in it, and I'd rather start off with a more complicated problem to show you how all the parts fit together. So the first thing we want to do is make sure it's in what we call standard form. And that's that equation I gave you at the beginning. The y equals a times, in this case, cosine times b parentheses x minus c, and then plus d. So if you look here, we start with our a value, which is okay. We're multiplying the cosine by a -2, so this is our a value. But in our equation, we usually have this b outside the parentheses. So if we look here, the number that's in front of x is 1/2. So what I want to do is factor out 1/2. And a lot of students have a hard time factoring out a half, but remember, when you factor out something, it's like division. And instead of dividing by 1/2, we're going to multiply by 2. So if I multiply 1/2 x by 2, I get x. And then if I multiply pi over 8 times 2, I get pi over 4. And again, you can always double check to make sure that when you distribute, you get back to your original. 1/2 x, 1/2 times pi over 4 is pi over 8, which is exactly what I need. Here is my c value. And if I notice, there is no d value, so it's a 0. And if d is 0, that means we don't have any vertical shift. Okay, it doesn't exist. So if I kind of go through that, I want to look at my a, b, and c right now to help answer these questions. A helps me find out these two parts. So I'm going to look at A for the reflection, A for the amplitude. A is negative, so that means yes, we are going to reflect. So whatever I normally think the graph is going to look like, it's now going to reflect over that middle line. The amplitude is the absolute value of this, so not -2, it's going to be +2. To find the period, we do, our formula says 2 pi divided by b. So I'm going to write this over here, 2 pi divided by the b value. Well, remember, we don't like to divide by a fraction. Instead of dividing by 1/2, we're going to multiply by its reciprocal, 2 over 1, which gives me a period of 4 pi. Now, both cosine and sine usually take, if we think of the unit circle, one full circle before it starts to repeat, which means the period is normally 2 pi. What I've now done is I've made it larger, so now it takes longer to repeat, so that would be stretching it out. So if we're thinking about music, it would be a lower, okay, tone note. Phase shift, how much do we move left or right? Well, if I look here, it's a positive value, which means I'm going to move the opposite direction. I'm going to move left, and we're going to move left pi over 4. Alright, so now this is a lot of information. How are we going to actually graph this? I'm just going to put some points on here just to kind of help you out to think of what a normal cosine graph looks like. So if I take the most basic cosine graph, just cosine of x, and don't think of any of this stuff, what it normally looks like is up 1, and then at pi over 2 it's at 0, at pi it's at -1, then here, then +1, then -1. It usually goes high, middle, low, middle, high, middle, low, middle, high. And it keeps doing this in both directions. Now this is not something you normally have to do, but I just want you guys to watch this for the video. You don't have to put this on your sheet, but just to see, this is normally what our graph would look like. Now it looks really stretched out right now because the scale is off. You know, the 1 is really low and 1 unit over is really spread out. But this is our normal basic graph. So what's going to happen is we're going to take this graph, we're going to flip it or reflect it. We're going to stretch it, and amplitude, if we're thinking of music, is how loud something is. Okay, so the higher and lower it goes, you know, the bigger the waves are, the louder the music would be. This is going to stretch it out. Normally it takes, if you notice here, it doesn't, if we start at 0 and go to 2 pi, and then it starts to repeat, but now it's going to take all the way over to 4 pi before it repeats. So it's going to, basically, if you think of this as like a slinky, I'm going to stretch it out. And then we're also going to take all of these points and move them left, pi over 4. And I'll explain to you where pi over 4 is on this. Alright, so where do we even start? I always start with the vertical shift, okay? Because right now, I have this, I'll use a highlighter for this to make it easier. I have this middle line right here. This is normally where it starts. Now, if I had to have a vertical shift, this line might shift up or down, but because there is no vertical shift, I know that my middle line stays right here, which is kind of nice. Alright, the other thing I'm going to look at, okay, so I would usually do this one first, but again, we don't have to worry about that. Now you have lots of different choices for everything else, but I always try to think about where my starting point is. This is my starting point right now. But what's going to happen is I'm going to have to do some sort of shifts to it and deal with this period of how long it takes. So I'm going to actually deal with the period next, okay, just to kind of help us out. And there really is no correct order that you have to do it in. But let's talk about the period. The period is 4 pi. So if I start at 0, 4 pi is way over here. Okay. Now if you think about how we normally divide up our cosine graph, it went 1, 2, 3, 4, 5 points because this started at 0. This would be straight up at the 90, the 180, the 270, and then back at the 360. Okay, those are our normal points. So if you notice, it breaks it up into here's quadrant 1, here's quadrant 2, here's quadrant 3, here's quadrant 4. So it breaks it up into 4 equal parts. So what you want to do here is take this distance and divide it by 4. So if the period's 4 pi, and I cut it into 4 equal parts to represent the 4 quadrants, that's pi. So if you notice, here's 0. I'm going to put a box at every pi. So that's 1 pi, 2 pi, 3 pi, and I end up at 4 pi. If you notice, this breaks up into quadrant 1, quadrant 2, quadrant 3, quadrant 4. It's kind of like what it does. It's stretching out those quadrants. They take twice as long now to get from one to the next point. Alright, so now that I know where my original points were, and now where it's being stretched out, I can now do a little bit more work. I'm going to erase some of these values just to make this a little bit easier for you to see. Okay. Normally I don't deal with all of those points. I just worry about the starting point. So again, this is my starting point because the pattern's really easy. High, middle, low, middle, high, middle, low. And all I'm going to do is change my starting point, and it makes it really easy. So if we think about this, normally we start right here at 1. But now my amplitude is 2, so I'm not going to start at 1, I'm going to start 2 high. Okay, again, my center line is going to stay right here. Do it with a red so it's not as thick. So here's my center line. Okay. Normally, again, we would have started up 1, but now the amplitude says 2. But I'm reflecting, so what that means is I'm not going to start 1 above the x-axis, or my midline. I'm going to start, 2 above. I'm going to start 2 below. So remember, this reflects it, so it flips it. So I'm not starting at the highest point now, I'm going to actually start at my lowest point. So instead of going high, middle, low, I'm going to go low, middle, high. Alright, what else do I need to worry about? So right now I've dealt with the reflection, I've dealt with the amplitude, I've taken care of the period, I've taken care of the vertical shift. And this last thing is the shift left or right. So I'm moving left pi over 4. So this is just 45 degrees. Now you don't have to know that, but it might help you to understand this. So if you notice, here's 0, here's pi over 2, which is 90. So here's 0, here's 90. Well, where would 45 be? Well, 45 would be smack dab in the middle, right? Halfway. If you notice how I made this graph, and all the graphs will look the same, here's 0, here's pi over 2. If you notice, it's broken up into 3 equal sections. Okay, 1, 2, 3. 1, 2, 3 for each of these. Well, if this is 0, 90, if you notice, this is 30, 60, 90. So here's your 30 degree, halfway in the middle is 45, here's 60, and that's how they're broken up. This is 90. This would be 120, 135, 150, 180. So you can break up the whole unit circle on this graph. Okay, and that's kind of why I have it. So if you look, 45, or pi over 4, is 1.5 spaces, but I'm moving left. So instead of starting my point here, I'm going to start right here in the middle. That's left 45 degrees. So now, how do I easily put the rest of these points? Well, if you noticed all these little boxes, I didn't start at 0 anymore. I actually started left 1.5 spaces. So all of these are going to go left 1.5 spaces. okay, because all of them have to be spaced out. Or you could count. The other way you could do it is if I went from 0 to pi, that's 1, 2, 3, 4, 5, 6 spaces. That's the same thing as if I start here and go 1, 2, 3, 4, 5, 6 spaces. Okay, all of these should be 6 spaces apart. Okay, so you have a couple of different ways to do that. So now what I'm going to do is, here's the low point. When I get to the next box, that's going to be at the middle, so on my midline. When I get to the next box, I'm going to go to the high point, which happens to be 2 because we're going up to 2 and down to -2. Then I get to the next box and I'm back at the middle. I go to the next box and now I'm back at the low point. I can keep continuing it. I'm at the low point. So if I went over 6 spaces, 1, 2, 3, 4, 5, 6, the next point would be back at the middle. And then all I need to do is connect these points. If you notice, this is way more stretched out. Instead of going up 1 and down 1, I go up 2 and down 2, and instead of going high, middle, low, I start at the low point. So it's always good to kind of know and darken in kind of your starting point. And that'll help me understand too and be able to grade to make sure you're doing it correctly. Alright, let's try another one. I know that can be extremely overwhelming. Once you get these, it's kind of like an aha moment. It's very basic. Every teacher probably does it a little bit differently. So I don't really care whose approach that you take. But this is kind of the approach that I'll take in class each time. So let me show you another one. Okay, so for our second and last example, we're going to be dealing with a sine graph. And if you kind of think about what we did for the original one, or if I look at the y values as I go around the circle, we normally start at 0. At 0 degrees, we're at 0. And then I go, if I'm thinking about y, I go from 0 up to 1, then down to 0, then -1, then back to 0. So we normally start at our middle value. 0 is our middle value, and then we go up to +1, which is our high value. So we normally go middle high. And we're going to see as we go through this if that's going to change, like our last problem when we had a reflection. So if I'm going to go through and put this in standard form, I'm going to start with y equals, my a value is 3. Now I don't see a b value, which is that number in front of x, which means that it's an imaginary 1. And since I don't have to factor out that, I can just write that in front. So it's x minus 5 pi over 6. That 5 pi over 6 happens to be my c value, and I have this +1 at the end, which is the d value. So now I'm going to take the a, b, c, and d and fill in my 5 questions. Does this graph reflect? Well, a is positive, so the answer to that is no. And because this is a no, my graph is still going to stay the same as my original. It's going to go from middle high, middle to the highest point, middle to the lowest point. If it reflected, it'd go middle to the lowest point, middle to the highest point. Any point on that midline won't be affected by the reflection because it's actually on the reflection line. Amplitude. A is 3, so the absolute value of 3 is 3. Period is always 2 pi divided by the b value. Well, 2 pi divided by 1 is just 2 pi. This tells me that this graph is going to look the exact same or have the same tone as our original sine graph. So it's not going to be a higher pitch or a lower pitch. It's going to look the exact same. If it was a slinky, stretched out the same. Phase shift, I look at the c. We do the opposite. Since it's a minus, I'm actually going to move right 5 pi over 6. Some people are going to be okay with thinking of this in radians. Some people might have to think about this as a degree later. 5 pi over 6 is 150 degrees. And because this is a +1, we're going to go up 1. Alright, so now how are we going to graph this? I always start with the vertical shift. That vertical shift takes my midline and moves it either up or down. So this is my original midline. But what happens now is because it's a shift up 1, my middle line, the line where all the middle points fall, is up 1. So that's what I like to start with first. Because there is no reflection, I know that my graph, when I get to my starting point, is going to start at some point on the middle and then go high. The amplitude is 3, which tells me from my middle line, the highest point is going to be 1, 2, 3 above it, and the lowest point is going to be 1, 2, 3 below it. So sometimes I darken this in. 1, 2, 3, 4. The highest point I'm going to go is 4. The lowest point is -2. And I don't have to worry about ever going higher or lower than that. I shouldn't have any points higher than 4, any points lower than -2. Alright, the next thing that I want to deal with is the period. So the period is normally 2 pi. So if I think of here's 0 and here's 2 pi, What I want to do is break that up into 4 equal parts representing the 4 quadrants. So you have a couple of ways to do that. If you don't have a graph that's already drawn out for you, you would have to take the period and divide it by 4. And what that's going to give you is how far apart each of your points are, which is pi over 2. Which means my first point would be at 0, the next one would be pi over 2 away, the next would be another pi over 2, or 2 pi over 2, the next would be another pi over 2, 3 pi over 2, and then another pi over 2, which is 4 pi over 2, or 2 pi. If you notice, all of my points are 3 spaces apart. How could I have easily got that? Well, if you think about this, if I go from 0 to 2 pi, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 points, or 12 spaces. If I take 12 and divide by 4, that means my points are going to be 3 spaces apart. So when I draw this graph, I know that each point, as soon as I get 1 point, I know the next point is 3 grid or units away. The next point 3 units away. The next one 3 units away. Okay, so do you have to draw this out? No. All you really need to know is that they're pi over 2 apart, or even easier than that, is that once I get my first point, the next one is going to be pi over 2 away. So that's what we're going to stick with. Get rid of all those extra markings. Alright, so where is that first point going to be? So now that's where this phase shift comes in. Normally, this would start right here in the middle. But because I have to shift right 5 pi over 6, which is not one of my markings down here, or 150 degrees, where would that be? Well, I know this is 30, 60, 90, 120, 150. Or, here's 180, my pi. I need to move 30 back, 30 degrees back, or pi over 6 back, and that happens to be right here. This is my 5 pi over 6. Remembering that these big grids, these are all 30 apart, might make it a little bit easier to find out where some of these shifts are. So here's my new starting point. I know that's right here. This is where I'm starting now. I know my next point is 1, 2, 3 away. 1, 2, 3. 1, 2, 3. I can keep doing this 1, 2, 3 all the way across. Now, do you have to do these little arrows? Not at all. If it helps you, great. But this is right here where my new starting point is. So now I know it goes middle, high. So here's the middle. At my next point, I know I'm going to go to the highest point, which I know is at the 4. The next point goes back to the middle. You always have to go to the middle. You never go from high to low. Because if you think about the unit circle, we go middle, high, middle, low, middle, high, middle, low. Then we go back down to the low, which happens to be at -2. Then back up to the middle, back up to the highest point, back to the middle. Okay? Now I can continue this in the opposite direction too. If this is middle, right before it would have been low. Whoops. Let me actually space that out a little bit better. I'll move this in a second. It should be 3 spots away. Make sure that's 3. 1, 2, 3. If I go 3 back, 1, 2, 3, I'm back at the middle. Back 1, 2, 3, I'm at the highest point. 1, 2, 3, I'm back at the middle. So you remember this goes on forever in both directions. And then what I would do is connect it with a nice smooth graph, making sure that the arrows go in the right direction. If you are at the lowest point, the biggest mistake people make is they're like, oh, I'm just going to keep drawing the arrow down. That's bad because, remember, the graph will never go lower than -2 and never go higher than +4. So if you're going to draw this, make sure you always curve at the top and curve back up at the bottom so it doesn't go on. And that's what I think is one of the easiest ways to graph a sine and cosine graph. I hope you feel a little bit better. We will be doing quite a few days of practice of this in class, giving you a bunch of different problems, but I hope you feel that you can find the amplitude, period, phase shift, and vertical shifts of the cosine and sine graphs, and that you feel that you're able to graph them from a given function.